All right, this problem says a rod of length 20 centimeters has two beads attached to its ends. The rod with beads starts rotating from rest. If the beads are to have a tangential speed of 20 meters per second in 7 seconds, what is the angular acceleration of the rod to achieve this? Okay, so here's a rod of length 20 centimeters. It has two beads at the end, and I guess they don't state this, but we'll assume that if the beads are to, okay, so I have to have a tangential speed of 20 meters per second. Okay, so if for both the beads to have the same speed, this guy has to be rotating about its center of mass. They have to be equidistant from the axes. Okay, and so we want this velocity. Okay, so actually, so here's a top view. It's rotating about that axis, and it's, let's say, rotating counterclockwise. So velocity is r omega. Okay. So let's calculate omega. What angular velocity do you need to have this linear speed? Okay, to have this linear speed. So 20 meters per second divided by 0.1 meter. So 200, the meters cancel per second, and radian is a free label. So 200 radians per second. Okay, again, remember, whenever you have linear quantities related to angular quantities, these angular quantities are in radians per second, radians, and so on. Okay, so what you need is 200 radians per second, the angular speed to be 200 radians per second after 7 seconds. This rod starts from rest. Okay, so now yeah, no, I converted, so the radius is 0.1 meters. That's what I have here, 0.1 meter. Is that what you're asking?
I see.
Right?
Looking at the 20 meters per second as the 27.
Oh, I see. Okay. Okay. All right. So omega is omega naught plus alpha times t. (200 radians per second minus 0 divided by 7 seconds). So this is the acceleration you need. Okay. All right. Any questions? That completes that problem.
So far, so good.
Well, that's good. So you're shooting for $1 this time.
I could get 50 cents, that'd be great.
Don't sell yourself short.